Ladies and gentlemen, welcome and thank you for joining today's web conference, ASF 3D Considerations webinar. Before we begin, please ensure you've opened the WebEx participant and chat panels by using the associated icons located at the bottom of your screen. Please note that all audio connections are muted at this time. If you require technical assistance, please send a chat to the event producer. With that, I turn the conference over to Liz Ferdinand. Please go ahead.
Good afternoon, everyone. I'm Liz Fernandez with the Professional Development Services staff, and I'd also like to welcome you to today's webinar. We have three speakers today. Mike Starkey is going to be our first speaker, and Mike is the Director of the Office of Emergency Preparedness and Response with the Minnesota Department of Agriculture. His main responsibilities are centered around collaborating with local, state, federal government, and private industry in preparedness and emergency response planning for food and agricultural emergencies. Our second speaker is Lori Miller. Lori serves as a Senior Staff Officer with USDA APHIS Veterinary Services, focusing on emergency response planning and preparedness in the areas of decontamination and disposal in the event of an animal disease outbreak. And our third speaker today is Mike Neault. Dr. Neault is the Livestock Unit Director for the North Carolina Department of Agriculture and Consumer Services since 2015. He previously held the position as the Michigan Department of Agricultural and Rural Development Animal Industry Division Emergency Programs Manager and is a past president of the National Alliance of the State Animal and Agricultural Emergency Programs. Just a programming note, we will be taking verbal and written questions at the end of these three presentations, but please feel free to add questions in the chat box throughout the presentation. And with that, I'm going to turn the webinar over to Mike Starkey.
Thanks, Liz. Today, I've been asked to kind of give lessons learned throughout some of the experiences that Minnesota had in 2015, and certainly centering around depopulation and disposal. But I think it's crucial, critical, I can't say enough, to the extent possible, understand industry, county, state veterinarian, state and USDA authorities, roles, responsibilities, and expectations on biosecurity, depopulation, disposal, and confidentiality. From a biosecurity perspective, on the index case, it starts, as John Zach said this morning in a previous webinar, at 0. At the infected prem, what does biosecurity look like? Where's the clean, dirty line? What instructions is the FADD going to give to employees, that kind of thing? What kind of PPE? What kind of disinfectants? And from the depopulation perspective, what kind of methods and field training is needed? From a disposal perspective, methods and field training, and there's always confidentiality. Next slide, please. So in Minnesota and in most states, we have our disposal options: burial, incineration, landfill, composting, and rendering. I've been on several webinars and conference calls. The folks are saying that they have a handshake or a gentleman's agreement with their landfill, that's where stuff will be going. Never rely on any of these four or five options. Never rely on them completely. They will come back to bite. Incineration. It's an opportunity or an option, certainly, but Minnesota certainly discovered it was low throughput, high intensity, resource intense, low throughput. On-site burial in Minnesota is really, really a challenge. We're certainly a land of 10,000 lakes and 100,000 ponds, so on-site burial is really challenging for us. And in 2015, we certainly looked at the rendering side, but they came back to us and said, what's the end game? How are we going to get rid of this stuff after we've processed it? And when we didn't have a good answer for them. Composting is definitely a science and an art. the challenge, again, it is both a science and an art, and it has to be done correctly. Setting, monitoring, turning, when can I move it, what's the carbon source? There's just a myriad of questions that need to be answered. Next slide, please. And then know the neighborhood. In 2015, this is a snapshot of one of our big layers in the lower center. There's a small town on the left, and on the right is one of the largest sugar beet processing facilities in the country. That was a challenge that the incident commander, myself, was absolutely unaware of at the time. We were in 2015, we were just marching. That egg layer did pop positive for influenza, so it was depopulated. The challenge is, as you see, it's right on a major highway in Minnesota and a major thoroughfare on Highway 21. It's in front of God and everybody when we start depopping. The exit or the exit for the layers was right on Highway 21, probably 40 feet off the highway. So is that important? Absolutely. First of all, we did have ideas that PETA was going to make a visit to Minnesota and really make a spectacle. So I met with the egg layer manager, and said, what can we do about this? And we suggested we needed to close that Highway 212, which is a big deal. So I went to the city to the left there, to the county, and we did finally get that done, but then I needed to propose that to the egg layer, and they were not happy at all, because they're 24/7. So just understand where you are in the event and the neighbors you have around. Keep that in mind. Lori, I'll turn it over to you.
Thank you, Mike. Well, hi, everyone. Really happy to have the opportunity to speak with you today. For this section of the webinar, I'd like to share some tools we've developed to help responders more easily develop 3D plans, and specifically, so 3D, depopulation, disposal, and decontamination, and specifically, I'm going to walk you through a new tool that was just launched yesterday for site-specific disposal plans. We have a template and all sorts of stuff that I'll get into momentarily. So first of the 3Ds is depopulation, and I know you can't read this slide, but I wanted to tell you about the document that it comes from. Everybody's been talking about worrying about African swine fever for the last several months, and as part of that effort, we have been collecting data, published articles and information from other countries on what practices have been effective under what conditions. And so at the request of a state colleague, we developed an ASF 3D summary chart. And it's basically a spreadsheet that has 3 or 4 tabs, one of the tabs being specific to each of the 3Ds. And this one is a screenshot of the depopulation tab. And the information here, this is not my area of expertise, but I did consult with veterinarians, and in fact, most of the information on this slide came from the Carthage System Professional Swine Management group. And the chart across the top has a variety of depopulation methods, everything from CO2 gas to firearms to captive bolt, even sodium nitrite. And each of the rows going down looks at, is it AVMA approved? What size animal is it applicable to? Small being less than 100 pounds, large being more than 300, and medium in between. Is there risk to human safety? What skill is required to implement the method? and what are the limitations, as well as even cost information was provided. So we do have this document. It's currently going through clearance at USDA, and we hope to publish it very soon. And so as soon as it is published, we would like to send it to people who are on this call and others who might be interested. And so if you have logged into this call using your email address, we will then send it to everybody that we have emails for. We'll send you this chart as well as a link to the dashboard tool that just went live yesterday. And one of the things we learned from talking to colleagues in Lithuania who have been fighting ASF for a while was they said it took them a few hours to euthanize 160 pigs, but it took them 2 days to get the pigs out of the pens. So that really underscored to us that it's best if the pigs can be moved under their own power. If they're too ill or if they have to be euthanized in place, there are carts available to make the job easier. Some producers have even discussed cutting holes in the exterior barn walls if necessary to get them out. So I just wanted to make folks aware of that challenge. And carcass handling, really is going to be a time-consuming and potentially risky operation. So to minimize the risk, some of those mitigations include using appropriate personal protective equipment when handling the carcasses and using automated means if possible. It can't be stated strongly enough that strict biosecurity will be needed. Notice in this photograph, the gentleman on the left has ripped coveralls. Unless the inner layer of clothing can be disinfected, that poses a potential source of virus spread. So strict biosecurity will be needed in all aspects. Now, once the animals are out of the barns and euthanized, if the disposal process is delayed, then the carcasses will have to be stored. During that storage time, leakage could be significant in the first few days after depopulation. The EPA did an exposure assessment recently, and they estimated that almost 2,000 gallons of liquid would be released from about 100 cows, which is equivalent to about 500 pigs. So 2,000 gallons of liquid for 500 pigs within the first week after death. So that's a lot of liquid. It's very important to contain that so you don't potentially spread the virus. So using some means, whether it's a non-porous base, so nothing can leak through, or if there's an absorbent material placed around, as well as a cover over the top, all of those efforts can help to minimize vectors and scavengers from disturbing the material. An inexpensive electrified wire may even be used to keep animals from scavenging. Now, for the second D, disposal, let's talk about some of the challenges and considerations for decision making. In order to get my head around this for African swine fever, I needed to figure out, well, what's an average size farm? Well, there really is no typical farm in the U.S., but I did go to the National Agricultural Statistics Service inventory from 2017, and the table on this slide shows the number of farms and the total number of animals at those farms. I did a little bit of math, came up with the averages and totals. Bottom line is, if you look at farms that have more than 1,000 animals, the average is about 6,800 head per farm. So I used that number later on in this process to use a calculator to figure out some of the options. But before going to the calculator and getting really specific, I wanted to just quickly review the various carcass management options and the considerations for each. We will look at on-site options, off-site options, and transportation. We've already talked a little bit about storage. So for on-site options, burning is commonly used internationally, and it refers to an on-farm pyre, air curtain incinerators, or even mobile crematoria. Although burning on-farm eliminates the need for carcass transport, inactivates the ASF virus, and reduces the waste volume, it does pose risk, potentially significant risk to human health. In 2001, in fact, the UK estimated that 3 kilograms of particulate matter is emitted to the air for every pig burned. And particulate matter causes human health effects like asthma and respiratory symptoms. Overall, burning takes a moderate amount of time to implement, has a relatively high cost compared to other methods, and has moderate risk to humans and animals. In terms of burial, which we can define as excavating an unlined trench or pit at least 6 feet below the ground surface, it's often the first option people in the U.S. think of because it's quick and easy, it's on farm, and out of sight, out of mind. However, there is risk of groundwater pollution from chemicals and even the virus unless the soils are suitable. And even if the soils are suitable, burial limits future land use. After high-path AI in the U.S., some farms that had used burial coined the phrase burial remorse. They realized once they had done it that they were, they may have had to put that information on their deed. It may have affected future ability to sell their property, and so overall it's quick and cheap, but it may have high risks. Composting is defined as a 1-foot layer of wood chips or other carbon source. Carcasses are placed on that layer, and then the carcasses are covered with another foot or so of wood chips or similar. It's been shown to be very effective. It can be done on farm, and it gets hot enough to inactivate many pathogens, including African swine fever. And it is relatively easy to implement. However, we used composting for poultry in 2015 extensively, and it worked great, partly because the birds are small, and we were able to turn the piles after 2 weeks and release them from quarantine after about 4 weeks. That's not the case with whole adult swine. It can take up to a year before those piles are finished, and that would potentially tie up the farm in a quarantine status. So in order to alleviate that, we're looking into the possibility of grinding prior to composting. Dr. Neault will talk more about that during his segment of this webinar. But overall, composting takes a moderate amount of time to implement and complete. It's moderately expensive compared to the other options, but it has low risk to human, animal, and environmental health. It also results in a useful byproduct. Rendering is the first of the off-site options we'll talk about. And so this involves transporting carcasses to a rendering plant where they are offloaded. They go through a grinder and subjected to heat, where 60% of the mass is driven off as a steam or water portion. 20% is fat or tallow, which can be used as a biodiesel, and the remaining 20% or so is a meat or bone meal, which is typically used for pet foods, animal feeds, and so on. However, there are concerns with rendering infected carcasses because it might affect the company's ability to market that end product as a feed. Even though rendering is specifically designed to recycle carcasses, it's well proven, safe, efficient, it gets hot enough to inactivate African swine fever, but just the stigma of it may make many renderers unwilling to take it. One of the strategies we've thought of is, if there's a way to separate infected animals from non-infected animals, even on the same farm, or certainly within a control zone, could we possibly send the uninfected animals to rendering? It turns out that many rendering companies may not even be able to take clean animals from a control zone because it affects their international trade agreements. So the most likely use of rendering will be if the rendering plant happens to be in the control zone. So overall, rendering is quick and has a moderate cost because of the transportation, but it potentially poses a high risk to the rendering company if consumers won't buy their products. Incineration refers to packaging carcasses into barrels or boxes, disinfecting the containers, then transporting them to a waste-to-energy plant for incineration. Because the plants are designed to safely burn waste, it is safe, efficient, and inactivates the virus. However, it might be challenging to package ASF-infected pigs into barrels or boxes, and there are a limited number of plants, waste-to-energy plants in particular, in the U.S. Overall, it takes a moderate amount of time and is low risk, but is relatively high cost. And that brings us to landfilling. Landfill involves transporting carcasses to a permitted landfill, which is designed to protect the environment. Landfills are safe, readily available, quick to implement, and they can often accommodate a large amount of waste. However, landfill companies may be concerned about taking infected materials because of public perception. They're afraid that if they take infected animals, that the liquids in the landfill called leachate will still have the virus, and if it's discharged to the environment, that it could spread the outbreak. And they don't want to do that. They don't want to be liable, and so they are reluctant to take materials. We have performed a risk assessment and found that especially if the leachate goes to a wastewater treatment step before discharge, there's virtually no risk of ASF spread, but there's still concern. So this is another great opportunity if we're able to segregate non-infected from infected animals, even on a farm. The non-infected ones would be prioritized to go to landfill. And it's in speaking with a few landfill operating officials, they indicated that if we certified that it was not infected, that they would take the materials. So it's certainly something to think about. Overall, landfilling is quick, inexpensive, and low risk. The last option I wanted to touch on is above-ground burial. This is still an innovative, sort of emerging technology which has not been fully proven, but it holds great promise. And we may need all the tools in the toolbox if we are faced with African swine fever, so we did want to include this for people's consideration. It involves digging a 2-foot deep trench, placing a foot of wood chips or similar in the bottom of the trench, placing the pigs on top of the wood chips, and then covering everything with the soil that was excavated from the trench. That soil is then planted with vegetation, and similar to composting whole pigs, it would take about a year for the pigs to break down, as long as the abdomens are opened before they are placed in the above-ground burial plots. We are also looking at the possibility of grinding. We're doing some experiments that Mike Neault will touch on, where we're going to see the effect of grinding the carcasses before above-ground burial as well as composting to see if that greatly reduces the amount of time. But we want to be certain that the procedure is safe before we recommend it for widespread use in case of an outbreak. Overall, it would take a moderate amount of time and is inexpensive, but until it can be fully validated, we would consider it to have some risk. just to summarize these various options in a very sort of a graphical way, just a general high, medium, and low risk in each of the high, medium, and low rankings for time, cost, and risk factors, and putting it into a graphic here, it turns out that landfill has the lowest time to implement, cost, and potential risk, followed by composting and potentially above-ground burial, while the open burning on farm would have the highest potential cost and risk and time factors. So if that's sort of a quick look at the various options. As I mentioned, we have begun experimenting with grinding to determine if it can be done safely. We know that reducing the size of the particles of the waste will help with composting above ground burial, but we want to make sure that the process doesn't create aerosols that might spread the virus. So we have a multi-stepped project going on in North Carolina where we are experimenting with different grinders, as well as we've enlisted EPA to help us with air monitoring to determine what the safety of this would be. In terms of transporting carcasses, there was a risk assessment performed by the University of Minnesota a few years back that looked at, tried to answer the question, could FMD-infected carcasses be safely transported, if necessary, to, from an infected farm to a disposal site? And the result was that if leak-resistant vehicles with liners and tarps were used, that it posed a low to negligible risk of infecting healthy farms along the route. And I just wanted to point out again that ASF 3D spreadsheet that I mentioned also has a carcass management section to it, which lists a number of different options, applicability, effectiveness, limitations, and also articles with data that support using or not using those methods. So people might find that very helpful for ASF planning. Now to the tool. As I said, this website went live yesterday, and it is intended to help people develop disposal plans. Unfortunately, there is no easy way to develop a site-specific disposal plan. There are all those options we just discussed. Each of the options has its own pros and cons, and it really depends what the site conditions are as to whether that particular option will work or not. So in order to help people sort of tackle that problem, we've developed this dashboard, and if you start with step 1 there, a window opens up and allows you to access the options, time, and cost calculator. By clicking on that link, you get a spreadsheet that opens up, and you're able to enter data into the blue boxes, and once that data is entered, it then generates information about the various disposal options based on the information that you've entered. So a closer view of that is this area where the data entry would be done. You can enter in the animal type, so I've pre-populated it with the swine, assuming they're about 300 pounds apiece, that there are 6,800 of them. They were affected by a virus. I'm assuming for the purposes of this exercise that the farm has only about 5 acres available that they could do without for up to a year, that they would could use for disposal, on-farm disposal. If they have to transport, they have access to 4 30-yard roll-off containers. And then the question is, in order to finish the calculations, we need to know how many miles are they from the nearest landfill, incinerator, or rendering plant. So to find that information, we have included a module which has a routing map. So the user would download that spreadsheet where they entered the information in the blue boxes. They would then go back to the dashboard, and on step 1B, click on the routing map. That would bring up a map, and the user can then enter their address, the premises address, into the map. And you may be able to see on this slide that there are a number of blue, red, and even a few little green symbols scattered around. L is for landfill, R is for rendering, and I is for incinerator. Once the location is entered, then the tool zooms in to that location. The user might have to zoom out a little bit to see landfills, renderers, and certainly incinerators. And then you would use the measurement tool at the far upper right of that window and drop a pin at the premises, drop another pin on the nearest facility. In this case, it's a landfill. And the measurement tool returns the number of miles, which in this case is 7.27. That process would be repeated for rendering and incineration. And then those numbers, the user would have to go back and enter those again into the spreadsheet that they downloaded, the calculator. Once those distances are entered, then the tool returns the results. The first thing the user might want to take a look at is the graph at the right side. And this is a quick summary where the green bars are cost and the blue bars are time. And so at a glance, the user can see, based on their inputs and a very detailed cost estimates, which we're happy to provide all the background and so forth. They've been thoroughly checked and reviewed. Just a quick glance at this, you can see that it looks like the quickest, fastest option would be above ground burial, but we just said that wasn't really proven. And the most expensive and most time intensive looks like on-site burning. So we might want to eliminate that right off the bat. But anyway, so that's just a quick view. Another portion of the results that are that come from the tool are two sets of tables. The on-site options are listed off to the left. The off-site options are listed to the right. And the data include the details like how many acres do you need for that technology. So, for example, in the top, it has calculated that you need 1.53 acres to compost 6,800 pigs. You have 5 acres available, so you could do composting on farm. It will take you really just a couple days to build those piles, but it all depends on how long they're going to have to sit there to finish composting. Is it going to be a month if they're aground? Is it going to be a year if they're not? So that'll have to factor in. It indicates that you'll need 540 tons of carbon source, and the total estimated cost is about $36,000. There are rankings for each option. So composting, you see, comes up in red. That's because it wasn't one of the top 2 or 3 options. And that's probably because it took a little longer or cost a little more, but it is very comparable in cost to the other options. They're, not that far apart. So it comes out the same in terms of cost as the landfill option. It's you can't really see it from this view, but anyway, so this is intended to help the user understand what might be possible on their farm just based on the amount of space they have time and cost. But that's not all there is to coming up with a site-specific carcass management plan. So going back to, again, assuming that the user has saved that spreadsheet on their computer, the user can then go back to the tool and go to step 2, which is to come up with a site-specific carcass management plan using this template that is provided. The other things that are useful on this page are going to be checklists to help folks decide if a particular option is going to work on their site, and also some planning guides to help them understand what supplies and equipment might be needed to implement their preferred options. So assuming that the user has downloaded, has opened the template, saved it on their computer, and they want to start filling it out, there's some brief instructions, and it's basically fill in the blank form. So it starts with just basic site information and then goes into the specific disposal options. And so it will walk the user through each of the options. Composting, for example, the first step would be for the user to indicate whether composting is or is not suitable. And so in this case, there's both in-house composting and outdoor composting. In-house composting really applies to poultry, so wouldn't be applicable here for swine. But how do I know if composting, if my site is suitable for outdoor composting? Well, excuse me. You would go to the checklist to help answer that question. And the checklist will ask questions like, is there enough area, land area, to build the compost piles? We already know from the calculator that there is, so I would check that. Yep. Oh, actually, I need to start at the beginning here. The very first question is based on approval of the state environmental agency and the composting subject matter expert from the APHIS roster, are site conditions suitable for composting the number of animals infected? The subject matter expert is not so applicable for planning purposes. It is very important if you're actively responding to an outbreak. But the state environmental officials are very important to this equation, because some states, for example, Minnesota, if the water table is at the ground surface practically, or if it's prone to flooding, then it's not going to be suitable, or you might not be allowed to compost at that location. So it's important to learn the rules, the environmental regulations of the state. And, you know, the easiest way to do that is to reach out to your state agency. You'll also want to look at the composting protocol. We have two of them. One is for poultry, and one of them is for livestock, and they are both accessible from that dashboard. And then you'll go into the specifics. Do you have enough land area? Yep, the calculator said so. Are you the required distance from water wells, surface water bodies? And that's usually, 200 feet or so, and more information on that is going to be in the protocol. So you go through this list, and you may find that, well, is it located away from neighbors or out of sight? Well, I'm right next to an elementary school. Maybe I don't want to be composting a bunch of pigs right out there in the back field. So maybe I don't want to use it for that purpose. So I might discard this option, and then I would go back to the template and indicate that it was not suitable. If it was suitable, however, I would continue on with the composting template, and I would indicate, okay, where am I going to get, what equipment do I need? Okay, skid steer loaders. Let's say I'm going to need, based on the composting protocol or my discussions with people, I'm going to need 2 of a certain size and type, but where am I going to get them? All right, I found them at this rental place, at this address, with this phone number. So it's very important to line up ahead of time exactly where you're going to get this equipment. And as Mike Starkey said earlier, even when you do that and you get verbal, even written commitments from suppliers, they may just not have any available at the time that you need them because of other commitments from the outbreak or otherwise. So, you know, it's good to have a secondary one as well. And, you know, this is a place to start. It's not perfect, but it's a lot better than not having any of this information when you need it. To get a better idea of all the equipment and supplies that you might need for this option, you would refer to the planning guides, which have links at the dashboard that I alluded to earlier. And, you know, this tool is not perfect. We welcome suggestions for improvement. It's sort of a snapshot of the best information and tools we have available right now. It will, you know, continue to evolve over time, and we hope that you will, you know, provide your input to help us do a better job so it's more useful for you as responders. Some other useful, we hope, parts of the dashboard include planning and training section, which has training modules, helpful links to other training courses, FAD prep guidance documents, and so forth. There's research, so based on related research articles that we have either participated in or found helpful, as well as deliverables from the projects that we have been conducting over the past 10 years. All of that is available at the research portion of the site. And then there's other tools and resources as well, which you might find helpful. So we will send you out that link to the brand new website, and hopefully you'll have a chance to look through it and find it helpful. And lastly, touching on the third D, decontamination, I just wanted to mention that there is also a section in the ASF 3D chart on decon, and we've tried to indicate, you know, specific information from articles that would support particular uses. So as an example, one of the decon options for outdoor areas might be fallowing. It is applicable based on a Perbrite study, which found that at 4 degrees C, which is about 40 degrees Fahrenheit, urine was from an infected animal was inactivated after 15.3 days. So a little more than 2 weeks at 40 degrees Fahrenheit, the virus was inactivated naturally. So that may be an important factor. Keep in mind, these are not regulations or standards. These are bits of data we've collected from articles that are out there. When standards and policies are made, they may be much more conservative. So as opposed to 15.3 days, it may be 30 or more days before, you know, fallowing is considered complete. But anyways, that is the end of my portion, and I'd like to hand it over to Mike Neault now for his section. Thank you.
Thanks, Lori. Basically, I'm going to talk about what we've been looking ahead at and preparing for ASF here in North Carolina. Lori, if you want to go to the next slide. In taking a look back over the last several years, many of our southern neighbors are in the same boat with us, where we seem to be geographically challenged in receiving hurricanes coming through. We had a lot more experience than we wanted to actually gain in actually getting used to doing some composting due to non-disease events. Next slide, please. In taking a look at what's happened over the last few years, in Hurricane Matthew, we lost 1.8 million commercial poultry, and fortunately, only 2,800 commercial swine based within the nursery. And then in Hurricane Florence, it went up to 4.2 million poultry, and the swine industry is 5,500. One of the things I'm just going to throw out there, I can't give the industry enough, and I have to say this here, is that they really did a lot of preparation ahead of time, making sure how they can move the animals out of the area for disaster And that really made our jobs much easier because these numbers could have been much, much worse. The flooding levels that came from these storms exceeded the 500 and 1,000-year levels in many of the affected areas. And the thing is, what hit during Hurricane Matthew were not the same flooded areas that developed during Hurricane Florence. There was really no way that you could go ahead and try and make a determination ahead of time where that piece is going to be. And that's going to be much like what the disease and its incidence is going to be out there when African swine fever does hit. Lori, if you want to go to the next slide, please. So we found out that the composting is the tried, true, and effective method. One of the things that we have out here in North Carolina that we have to be very aware of is the water tables that we do have here in the state and how high they are. And so composting for us really is one of the best methods, really to try and reduce as much environmental impact that a mortality loss like this would actually affect things. As Lori mentioned it earlier, and I'm just going to reiterate it here, one of the lessons definitely learned from the last hurricanes coming through, I can't stress how important it is to go out there and for industry and state to look at trying to develop the contracts ahead of time pre-event for the carbon material. Some of the equipment that we'll be showing here later on in the slides is not going to be the easiest equipment to be able to potentially get hold of, and then also trying to make sure that you got your subject matter experts ready ahead of time. Next slide, please. Looking here, this is what it looks like with the swine industry here in North Carolina. So this is what we would have to be preparing for 9.4 million head of swine in the state. 3 of the counties are the heaviest part of where everything is located at for our commercial industry in the state. And as Mike Starkey had mentioned earlier, when John Zach was talking about developing zones, for us it's not, and we can imagine hitting 1 county, 2 counties pretty fast in the start of this, and we have to start laying down what our zones are going to be during this. Lori, next slide, please. So the question that comes from everything is, can the composting process be improved? And this is not a new concept. This is something that's actually been brought up at several of the international symposiums on animal management mortality. And I'm sorry, unfortunately, the little video piece on this one and the slide there is not working, but just to let you know, on that huge water ban, somebody just went through with the Dremel 2 tool, got a little saw to it, and you can watch that thing just break open. And honestly, that's kind of what we're really kind of talking about with the carcasses here. What happens if we do some pre-processing of the carcasses or grinding and break that water balloon? You get that moisture out. You get the tissue broken down more. You get it mixed better with your carbon source material. What will develop from that? Will that give you quicker composting? Will the temperatures rise and be acceptable faster? And then also, will it enhance the absorption of the liquids into the carbon material by breaking things down instead of waiting for it to slowly leach out on there? And then we do know that on the commercial side, there are units that are now available that are being used for daily die-off in the poultry and swine industry. Lori, you can go to the next slide, please. So what we're taking a look at is the commercial units that are available at this point in time, and what were initially discussed at those symposiums, we're really taking a look at the vertical. What can you put behind the tractor, connect up and let that tractor engine go ahead and run and do the turning as far as the mixers with it. And that works great for normal die-off, but when you start to get into the numbers that we could be talking about here, that's not going to be effective. And so the next phase is, well, what can we do to start to take a look at these horizontal grinding units that exist out there? These would be the units that are used for grinding trees up to go out and then make the wood chips, much as are demonstrated in the pictures here. Next slide, please. So we had our first trial back in February in Clinton, North Carolina. Lori had shown one picture earlier. One thing I'm just going to point out into this picture that's here off on the side, I'll come back to it at the end of the discussion. I just want you to take a look at the distance that you're finding that the conveyor belt is actually pushing the material off after it's been ground with some carbon source material. So what we did in the, thanks through corporate agreement and working with different groups, we were able to get in a first trial in Clinton, North Carolina at one of our research stations. We did take soil samples at the site where the compost pile was being created. Unfortunately, when we took soil samples at the end of when everything's been composted and the pile was removed, unfortunately, I just don't have that information to be able to share with what the values were in the soil pre and post. When we get it, we'll be willing to share that as it moves on. We did have one of the industries came forward and donated 60,000 pounds of various sized carcasses, swine carcasses for us out there to go ahead and use for the demonstration. We rented a horizontal unit from a FEMA contractor. It was 1,100. Sorry, got a little too high. It's not 1,000 horsepower unit. With two, and basically these units have screens that you can attach into those right there. And with those screens, what happens is that as the wood or whatever material gets in there, it has to go down to a certain size to get through that screen, and then it'll come off on the conveyor belt onto the other side once the grinding has been done. In this situation, we had two screens available to us. What ended up happening is that the third screen was unavailable at the time that we did this. What ended up happening out there is that we got a really fine sawdust-like material from it. And it did a very good job of grinding. It's just unfortunately it was a little too good of a job of grinding. Sawdust material is not necessarily what you want to use for composting out there. So that was one of the first things learned in the trial on that one right there. Lori, go to the next slide, please. Looking here, I just wanted to share at least the temperature data range that we did get from it. We did this on February 21st, and then if you start to take a look, we had exceeded, we measured in two different areas. You go into a short depth, which is the 18-inch depth, which is nearer to the surface. That area, because of the airflow coming in, will heat up faster than the deeper depths will in the compost pile. That said, if you take a look, we had a really nice rise in temperature. The temperature range out there during the first 30 days of this trial ranged from about 80 degrees tops during the day, and that happened in 1 or 2 days during the first 30 days. And it did make it down to 31 degrees at night. It was probably about an average 60-degree top during the day, 45 at night. So if you take a look at a spring/fall type temperature with a little bit of for some of the northern states, you have a little bit of winter temperatures in too. When you start to take a look at things, it worked out really pretty well. That within the first 4 days there, we hit above 120 degrees Fahrenheit on pretty much both definitely on the upper thermometers, and the lower thermometer followed about a day or two later with it. And as it started to go out, when we started to take a look at everything with it right there, it did reach 140 degrees by March 5th, and both internal and external reached it at that time. Deep temperatures measured on May 31st, 2019, were still at 132 degrees Fahrenheit. We are looking at trying to achieve temperatures, and I'll have Lori correct me on this one if I get this one wrong here, is that we're trying to get to that 130, 131 degrees Fahrenheit and have it sustain that for 72 hours. And if you take a look at what we've got here, we've actually accomplished that fairly early with the grinding project right here, which is good. That's what we wanted. And by 3 months out, we're still at 131 degrees in the pile. So things were going and cooking just like we had hoped that they would be able to right there. And we did not turn these piles. These piles were just left as static piles. They produced some pretty interesting temperatures on it. Lori, if you want to go to the next slide, please. And I'm going to correct this again. It's a 550 horsepower unit that we got for our second demonstration in the trial here at the same research station that we just started 2 weeks ago. We had 16,500 pounds of various sized swine carcasses again donated to us for this. The unit again was rented from a FEMA contractor. 3 screens were available to use. We used the third screen to start with, which is the one that we did not have available to us in our first trial, and it produced a very good material for composting. It was just the right size for what everything needed to be right there. That said, the piles that we are creating now are actually going to be used in a train-the-trainer course that we are doing for our producers in September 2019. The University of Maine is bringing their USDA course down to us, and we've got above-ground burial trial site. We've got pre-processed composting and traditional composting. For the above-ground burial trial that's going on, I don't have data for it just yet from what the thermometers are starting to read inside those piles. And we've got two different types of above-ground burial going on. We've got one where we've gone through pre-processed, ground up the carcasses, and have that mixed with carbon material in one set. And then we also have carcasses left intact. However, as Lori mentioned, they were opened wide to go ahead and prevent issues on there. Lori, if we can go to the next slide, please. Early data that came back, now this is the first 3 days, and unfortunately, I just got today, unfortunately, I guess I got today, I've got some additional data I should give. For the first 3 days, there's 93-degree ambient temperature outside, so the thermometers did read that. If you take a look by day 3, our external, our upper-level thermometers reached 120, and at that point in time, we were roughly about 102, 105 on the internal or on the deeper thermometer in the whole swine carcasses. Where we start to see some differences is by day 3, we had already exceeded 140 degrees, and we're close to about 150 degrees on the external temperatures for the process, ground up carcasses. And the deeper thermometers were already at that point in time roughly about the same as where they were, or well, actually they were higher than what our whole carcasses was at around 120 on that end right there. So we were getting some really, we're getting what we really wanted on that part there. Trying to pull up some of the additional data that we just received today that we're just in the process still now trying to take a look at here in interpreting. I do have to say that we did exceed 140 by 6 days out on the on our whole carcass composting, and then when we start to take a look at what we had with our carcass or our ground carcasses again, they had actually exceeded 160 degrees by day 5 or 7 into the whole process. So we really did get some really nice heating that we want. The goal here is really to try to get the heat up there at a good appropriate level to go ahead and kill the virus as much as possible on that. Next slide, please. And again, these are just quick snapshots of that right now. So as we're taking a look at the use of these commercial horizontal tree grinders, we did find that they were effective in what we had. And then we found it actually worked well in I'll have to say that the 1100 horsepower unit definitely did a better job on the larger sows. However, that 550 horsepower unit also did a good job. What the difference was is really pretty much negligible on what we saw right there. The acceptable temperatures had been achieved in composting piles using a 1-to-1 ratio of pre-processed swine carcasses and the carbon material. The trials are still, above ground trials, like I said, are still in progress, so I don't have any further information to share except what we're doing with that piece on it right there. And then we believe that running the numbers through this, that if you're looking at one of these units that are operating, we found that both, like I said, the 550 and 1,100 horsepower units ran just about the same. So we found that each unit operating at probably 1,200 pounds of carcass per minute throughput. We're looking at a 5,000 head finishing farm with animals roughly 250 pounds each. That could be processed in approximately 17 hours of runtime of that unit. With separate grinding and window building operations, we're probably looking at a throughput of about greater than 1,200 pounds carcass per minute can be achieved, if not exceeded. So future trials that we've got here are going to be looking at what can we do. As it's demonstrated on that first slide that I had shown right there, the units do throw fairly far. EPA did have some monitors out there with us as they're working on the project with us and captured that, yes, particulates were captured in those monitoring units. Right now, it's still being processed to take a look at pathogens to see what would happen there. We're taking a look what can be done to mitigate by potentially using some sprayers on our next trial to see if that will at least, using some sprayers, misters, to be able to go ahead and cut that down. Other things to keep in mind, if this is a virus that is an airborne transmissible virus, you're probably not going to, you're going to be more selective on the type of process that you use on this unless it can create some other mitigation to keep that down, because we don't want that to be spreading. And then we're also going to be taking a look here at some other livestock species coming up on the next trial with, I think, at least a couple of cow carcasses, potentially, if things work right on it. And then the last thing, too, is that there's going to be some weather-related issues on this. Our first trial was pretty much a calm day in February, and then we had a bit more of a nice windy day 2 weeks ago, where when they got the carbon material going through it, you could follow that sawdust going down and track it down quite a distance as it went through. So I guess the other thing that it could be, again, there are a lot of good things for this. We'll be finding out a little bit more. I think one of the other challenges that we may be having with this is just trying to determine how many of these units actually exist out there. Next slide, please. And I'm just going to acknowledge the people who helped us out during these trials with Advanced Composting Technologies, AG Protein, EPA, North Carolina Department of Ag, United States Department of Ag, University of Maine, Virginia Department of Environmental Quality, and Virginia Tech. And with that, Liz, I'm turning it over to you.
Okay, thanks, everyone. We really appreciate that. We are going to do a Q&A. We'd like to start off with some questions that we've already have in the chat. Helen, if you'd like to explain to everyone how to do a verbal question, that would be great at this time.
Yes, certainly. So if you'd like to ask a verbal question through the telephone, please press #2 on your telephone keypad. You will hear a notification when your line is unmuted. At that time, please state your name and question and who you'd like your question addressed by.
Okay, so let's start out with our written questions. This one is for Lori Miller. It says, landfilling options for carcass disposal. During 2015 HPAI outbreak, although landfilling became an extremely important method in the state in the end, it was only after Governor became involved that the landfill began accepting carcasses and contaminated PPE. In the event of another outbreak of similar magnitude, what influence, if any, would or could USDA have with the states to gain compliance for this practice? Is there any provision for this within cooperative agreement money?
Thank you for the question. So it is possible that we would, need governors to make declarations or otherwise intervene. If we are able to segregate non-infected animals from a control zone and prioritize those for landfill, that would certainly alleviate the issue. And ultimately, unless it's a government-owned, so a county landfill or a municipal landfill that is run by the municipality, paid for by tax dollars, there's not a lot we can do to get landfills to take materials. If they're a privately owned company, it's really up to them to choose to accept materials or not. We do hope, like I said, that if we can segregate infected from non-infected, that will go a long way into taking advantage of the landfill space. And in terms of provisions within cooperative agreement funds, the Farm Bill is now in place for for livestock. The announcement's coming out in the next couple weeks, and so I would encourage people, if you have an idea for a project and it fits within the scope of the Farm Bill language, that you apply for that. I hope that helps.
Thanks, Lori. The next question, is there a way of removing the landfills that are too small to accept any number of livestock? This person noticed that in Kansas that a lot of our small landfills were on the map. They max out at 20 tons per day, which means they would not be an option.
So what I would recommend in that case is, one of the advantages to using the template is that it provides blanks for you to reach out to people. So you would really have to call the landfills. The advantage of having that mapping tool is that, at the bottom of the page, it lists all the landfills, rendering plants, and incinerators with contact names, phone numbers, latitude, longitude, all that information. So you're able to see on the mapping tool which ones are, which. There is another database that EPA maintains that includes size of landfill, but really short of calling the landfills and asking them, there is, not much else automated that I know of. But reaching out to your state environmental folks, they probably know right off the top of their heads which ones are, in really strict compliance with all the regulations, that have lots of capacity. So, I am very much a fan of reaching out to your state environmental folks. I don't mean to overwhelm them and tell everybody to call them, but you're such a wonderful resource that I think it's very valuable.
Okay. The next question is, the speaker mentioned it takes a year to compost swine. That seems like a very long time. I know the large bones take longer, but to get to the point, if the material is no longer infectious, would it really take a year?
So if the carcasses are whole, it just takes a long time for those large leg bones to fully decompose. Whether or not there would be any live virus in those piles with whole carcasses for a year, we don't know. We are doing a study in Oklahoma where we're looking at survival of a surrogate virus in bone marrow in sow femurs. So we'll have some more data about that over the next year. However, if the carcasses are ground, then that bone marrow would be available to decomposition just like all the other tissue, and it would not take a year. In that case, we would expect, with grinding, we would expect it to take, 2 weeks for the first turn, 2 weeks for the second turn, and then release from quarantine, just like poultry.
The next question is, have you looked at silage choppers?
So I'm not familiar with that equipment. Any of my co-speakers know what that is?
I know what they are, yeah, Lori, but I'm not sure silage. Would that have to be researched? Sorry.
Okay. The next question is there a virus surrogate recommended for chemical disinfectant testing with ASF?
So over the past few years, USDA has collaborated with ARS, so APHIS and ARS have teamed up. There was some research done at Plum Island where they used actual ASF virus with citric acid and sodium hypochlorite or bleach. So the first part of that answer is the best data is from using the actual virus. The challenge with ASF is that it is in its own family. So there aren't any other really closely related viruses that are safe to use outside of, a high-level containment lab. We have found a swine pox that used to be categorized with ASF in the same family, but then they were later separated. So it's that swine pox virus that we're using in our study on the sow femurs. But other than that, our research has shown that the virus behaves differently depending on, so we've taken surrogates and compared them to actual viruses, particularly in the case of foot and mouth disease. It was done on Plum Island. We found that sometimes the surrogate behaved just like FMD, sometimes it didn't. And it depended on which disinfectant you were using and what the surface was. So, no, the answer is no. There's no virus surrogate recommended with ASF.
So here's a question for both Mikes. Did you move contaminated material over state lines, and was that an issue?
Minnesota, no. Not that I'm aware of.
And I'll be honest here, we didn't have any contaminated tissue on this one. There's just normal die-off.
Okay. Our last written question, we're coming up on our end of the webinar. The last question I have are, what are the time and temperature requirements needed to inactivate the ASF virus in a composting scenario? And can a combined carcass disposal solution be implemented, i.e. ASF inactivation in a premise and eventual transportation to a landfill?
I'm happy to start with that one. So I don't have the numbers in front of me at the moment, but from what I recall off the top of my head, 140 for several hours, 140 degrees Fahrenheit for several hours would be sufficient. I think it was 3.5 hours, would be sufficient to kill the ASF virus in meat, if I recall it. So this is all in the ASF summary chart. So I apologize, I don't have it in front of me, don't recall exact numbers, but it was something in that neighborhood. So it's similar to cooking. So if the virus can be killed at 140 for 3.5 hours, then composting for, a month at high temperatures in the range of 120 to 140 should also be effective. And in addition to that, composting has been shown to inactivate a whole host of viruses and bacteria, including spore-forming bacteria, in deer carcasses. Cornell University did that work. And so pathogens that are hardier than ASF were inactivated eventually with composting. So therefore, it is likely that composting would also inactivate ASF. Regarding a combination approach, it is possible that you could treat at a premise and then transport to a landfill. The landfill needs a waste manifest. Basically, they need a document that says, I am the generator of this waste, and I, hereby declare that this waste material does not have any hazardous, constituents in it. So if somebody signed and said it's no longer infected, then the landfill could take it.
Okay. I do have a verbal question with someone that's sitting in the room with me. I'm going to pass it over to Greg Mayer.
Hi, this is Greg Mayer, and my question's for Dr. Neault. Did you have any problems with feral swine trying to get into the above-ground heaps that you were working with?
On the 2 trials that we've had so far, we haven't had any issues with the feral swine in that part yet. That is something that we were trying to monitor and make certain on that, too, for the exact reason we didn't want it to spread.
And also some other data from Virginia. We did a small-scale project last year, and we set up trail cams to watch the piles. So for the above-ground burial plots, over a year's time, we saw a bear walk by, we saw a fox walk across the piles, but nothing dug into the piles.
Excellent. Thank you.
Do we have any other questions, verbal questions in the queue?
No, we don't have any questions on the telephones at this time.
Okay. Well, since we're running out of time, I'm going to go ahead and thank everyone for your participation today. I just want to let everyone know that's still on the webinar. We do have another webinar on Thursday, August 8th at 11 a.m. Eastern Standard Time with Dr. Ross Free. Dr. Free is going to be speaking about the swine herd plan, and we certainly hope you can join us. And have a great afternoon, everyone.
Thank you.
And that concludes our conference. Thank you for using AT&T Event Conferencing Enhanced. You may now disconnect.